In the cold vacuum of space, survival without protection is impossible. Not to mention the fact that even on neighboring planets, the conditions are unimaginably deadly. Each planet in our solar system offers a unique and horrifying way for an unprotected human to die. Today's journey is both mysterious and educational, as we'll step into the body of a hypothetical, somewhat careless explorer and find out what the final moments of life might be like on each planet. Today, we'll visit the blazing daylight of Mercury, the crushing inferno of Venus, the suffocating cold of Mars, the depths of gas giants Jupiter and Saturn, and the frigid, stormy skies of Uranus and Neptune. Each environment presents its own nightmarish scenario, and as we travel through these hellish realms, remember, unlike them, Earth is a rare oasis where life thrives. So let's begin with the innermost planet, where dawn breaks in a world of fire and silence. We begin with Mercury. Here, the unfiltered glare of the sun scorches the ground. Daytime surface temperatures reach up to 800 degrees Fahrenheit, hot enough to melt lead. There's virtually no atmosphere to diffuse sunlight or offer protection, so solar radiation strikes with full force. Stepping onto Mercury's sunny side, an astronaut would be subject to extreme heat and intense ultraviolet radiation immediately. All exposed skin would begin to sear and blister. The airless environment means no oxygen to breathe and no medium to transfer heat. Your shadow on the ground would be razor sharp. The sky remains black, even at noon, since there's no air to scatter the light. In this near vacuum, the moisture on your tongue and in your eyes would also begin to evaporate, an eerie parallel to the conditions of open space. Within seconds, catastrophic overheating and asphyxiation would happen. Your first sensation would be a wave of heat across your suit and body. Even with insulation, cooling systems would be overwhelmed almost instantly. The landscape offers no relief, just a gray, moon-like expanse of rock and craters burning under the rays of the sun. Mercury's weak gravity, about 38% of Earth's, might make you feel light, but the heat would be unbearably heavy. It's like stepping into a furnace. Within moments, your lungs would gasp in vain, since there's no air at all, and your vision would blur as your brain is starved of oxygen. You'd collapse within 10 seconds, burned and suffocating. Yet, despite such extreme conditions, if you found yourself on Mercury's dark side, you'd freeze to death, a stark contrast. In the absence of sunlight, temperatures plummet to minus 290 degrees Fahrenheit. Now let's move to Venus. The environment here is often described as the closest thing to a literal hell. The atmosphere on Venus is extremely dense, about 92 times the pressure of Earth's, akin to being submerged nearly a mile underwater. The air is a toxic brew of carbon dioxide, laced with clouds of sulfuric acid. Surface temperatures reach around 873 degrees Fahrenheit. Paradoxically, it's hotter than Mercury despite being farther from the sun. Simply being on Venus means confronting heat capable of melting lead and zinc, and pressure that could crush a submarine. As you descend through Venus's thick cloud, sunlight turns into an eerie orange glow. You might catch a glimpse of the barren, rocky landscape before the cloud cover swallows everything in thick hazes. The very air is poisonous, filled with CO2 and nitrogen, and completely devoid of oxygen. Upon landing, a person would be crushed and roasted instantly. The pressure compresses your body with force strong enough to crumple a steel plate. All the gas pockets in your lungs and sinuses would be brutally squashed, and simultaneously, the immense heat scorches your flesh. moisture evaporates and organs begin to fail within seconds. The corrosive air also contains droplets of sulfuric acid, but oddly enough, you won't be drenched in acid rain on Venus. The acid evaporates before it hits the ground in a phenomenon known as virga. Still, that's little consolation. The ambient heat is so intense that even without acid, metals around you glow a dull red. Within moments, the visor of your helmet would soften and melt, and all exposed skin would char. The crushing weight makes movement impossible. Your knees buckle, your body compresses, bones crack under the immense pressure. It feels like an elephant is standing on every inch of your body. The toxic, superheated air entering your lungs scorches them from within, and less than a second after exposure, you would lose consciousness. Your body, if it somehow remained intact, would be dissolved and incinerated into Venus's rocky soil. This is death by total environmental overload, pressure, heat, and acid working together to erase all traces of human presence. Flying past our blue oasis, we find ourselves on Mars. The red planet may seem appealing compared to Venus, but an unprotected human still faces a quiet, suffocating death here. The Martian atmosphere is extremely thin, less than 1% of Earth's, and composed mostly of carbon dioxide. Essentially, it's close to a vacuum. There's virtually no oxygen to breathe, and the atmospheric pressure is so low that liquid water would instantly boil away. The temperatures are also very low, averaging around -76 degrees Fahrenheit, but they fluctuate from a mild 68 degrees Fahrenheit at noon to a frigid -220 degrees Fahrenheit at night. Standing on the rust-colored sands of Mars without a spacesuit, the first thing you'd notice is the sky, a hazy iris color, and the horizon dusted in red. You wouldn't hear the wind in your ears, although Mars does have wind. The air is too thin for you to hear it. After a few seconds, the real danger sets in. You cannot draw a breath. When you open your mouth to inhale, nothing happens. Due to the lack of atmospheric pressure, the saliva on your tongue and moisture in your lungs begin to boil. A chilling but painless hissing sensation in your body. You feel your skin tightening. While it won't explode, the fluids in your blood will begin forming gas bubbles. Oxygen deprivation sets in quickly. You have roughly 15 to 20 seconds before you lose consciousness. In that time, your body also begins losing heat. The Martian air is so thin it can't conduct heat very well, but the evaporation of moisture from your eyes and lungs creates a powerful cooling effect. Any exposed skin rapidly senses intense cold. Your vision narrows and darkens as your brain runs out of oxygen. You might feel a tingling sensation as blood vessels rupture under the pressure difference, or taste a faint trace of iron as capillaries burst. After about 30 seconds, you'll lose consciousness from hypoxia. Soon after, you'll die quietly in the brutal cold of this red planet. Your corpse undergoes sublimation. In such low pressure, your blood boils and your body temperature plummets. The frozen desert of Mars effectively mummifies what's left of you. The coroner's verdict? Asphyxiation and ebullism. Yet, compared to being burned alive, this death could almost be called peaceful. Perhaps Mars was more hospitable in ancient times, but today it is a graveyard for the unprepared, a place where the simple act of breathing becomes an unbearable torment. Let's move to the outer solar system. What would it be like to land on a gas giant, you ask? Falling into Jupiter is like descending into a planetary abyss. This giant has no solid surface. What appears to be surface from space is just the top of its cloud layers. As you enter Jupiter's atmosphere, you plunge into a world of colossal storms and crushing pressure. The upper layers seem deceptively gentle. Pastel bands of orange, white, and red drift beneath you, and you enjoy a brief moment of free fall under the dim sunlight. But the situation quickly changes. Jupiter's gravity, which is more than 2.5 times that of Earth, pulls you downward with increasing speed. The air around you thickens with hydrogen and helium gases, and soon you encounter winds beyond anything Earth has to offer. Jet streams, moving at 400 miles per hour, tear through the clouds. These winds will toss you violently as you descend. Massive storm systems, some large enough to swallow Earth, loom in the atmosphere. Perhaps you're falling into the heart of the Great Red Spot, a storm that's raged for centuries. In the dim light, lightning suddenly flashes across the sky. Jupiter's lightning bolts can be 3 times brighter than those on Earth, briefly lighting up those murky clouds, and thunder is replaced by an all-encompassing roar of wind and atmospheric turbulence. You fall deeper, and the pressure increases relentlessly. At a depth of about 30 miles, the pressure already exceeds Earth's by several times. Go further, and it's dozens of times more. The temperature rises too, from around -150 degrees Fahrenheit in the upper clouds to well above the boiling point as you descend. Your unprotected body is trapped between pressure and heat. The air becomes as dense as water, treating you not like a skydiver, but like a deep-sea diver. At 10 to 20 atmospheres, human flesh compresses and the lungs collapse. Any hollow spaces in your body, sinuses, inner ears, they rupture under the strain. As the gas around you thickens, your body is compressed into an even smaller volume. Now, the world is completely dark. Sunlight cannot reach this depth. The only illumination comes from occasional lightning bolts and the eerie glow of distant electric discharges. Your bones begin to crack as the pressure climbs into the hundreds of atmospheres. Ferocious winds tear your body apart, and eventually, the combination of pressure, heat, and mechanical stress vaporizes you. Your molecules blend into Jupiter's vast atmosphere, long before you ever land on any kind of surface. Consider this: even robots have a hard time surviving Jupiter. What is there to say about humans? The Galileo probe, which entered the planet's atmosphere, was destroyed by its pressure and heat. For a human, there's no hope, except for complete dissolution in the belly of the solar system's largest planet. As we've just seen, each planet in our solar system holds its own unique horrors for any unprotected human who dares to visit. From being incinerated in seconds on Venus to being crushed and dissolved in the depths of Jupiter, space is not just hostile, it's unforgiving. Yet it's in this vast cosmic danger that we find a deep appreciation for our own planet. Earth may seem ordinary, but compared to the rest of the solar system, it's an unparalleled sanctuary, a rare jewel where life not only survives but thrives. The more we understand these extreme environments, the more we value the fragile bubble of conditions that allow us to live and grow. If this journey through the deadly realities of our neighboring planets fascinated you, imagine what else we'll uncover together. From black holes to alien life and time travel to the fate of the universe, this is just the beginning. So, if you enjoyed this video, make sure to like, subscribe, and hit the notification bell so you never miss a mind-bending episode from Infinite If. Every week, we dive into the most thrilling what-if questions the universe has to offer. And trust me, you won't want to miss what's coming next. Until then, stay curious and keep looking up.